In this section, we're going to be working on writing linear equations in point-slope form. So that's a new form, and that's what our learning objective also is to write equations of lines using point-slope form. So you may have noticed that the method that we've been practicing is a little unwieldy. Okay, it takes two steps. It's first I calculate the slope, and then I plug and I find m, and then I plug in the x and y coordinates from a point, and I can find b, and then I assemble the equation. Well, point-slope form is really just a form that allows you to do all of that in one step. So if we want to look at point-slope form, that's right here, and it's y minus y1 equals m times x minus x1. And in fact, what I want to do is I want to separate that out in terms of not just highlighting it, but I want to point out the parts that you put in are these three parts. Okay, you put in the slope and the x and y coordinate from a point. That's why it's called point slope. X and y, the items I've shown you here in green, x and y stay x and y. We need them in our equation for y equals mx plus b. Okay, so what it allows us to do is it allows us to take, we're going to calculate the slope, right? If I don't have the slope, if I have 2 points, what changes in point slope form is how you find slope. So in this case, they're giving it to me. So, and I've got my x1 and my y1. So I know I'll have y minus y1 is equal to my slope, -6, times x minus x1. And when I simplify this, I'll have y plus 1 is equal to -6x plus 42. And when we subtract 1, y is equal to -6x plus 41. This is my equation. So you see, I could have done the same thing before by taking y equals mx plus b. Right? The only thing I'm missing is b. I know my b should come out to be 41. So I know y was -1 when slope was -6 and x was 7. And you'll see I'll have -1 is equal to -42 plus b, and when I add 42 to either side, I'll get b is equal to 41. The nice part about this is it finishes in y is equal to mx plus b format. So it finishes in my standard equation for a linear equation, and I don't have to go back and rewrite it by knowing, okay, well, b was 41 and slope was -6. I don't have to do that. Okay, so if I want to graph something in point-slope form, I could do that a number of different ways. But for right now, I can see that I can get the slope and the point from that. So let's take a look at what we've got. I know that my slope is equal to -5/2. Remembering I'm doing y minus y1 is equal to slope times x minus x1. So I'm looking at the parts. I know that x1 was 3, and I know that y1 was -4, because y minus -4 is what gets me y plus 4. Okay, so if I start with this point, 1, 2, 3, and then down 4, there's that point. And then I want to follow my slope. So I could go down 1, 2, 3, 4, 5, and right 2. Or I could go up 5, 1, 2, 3, 4, 5, and left 2. Oh, look at that. That's my x-intercept. It's not my y-intercept. Okay, and that allows me to go ahead and graph the line. Okay, so what did I do? I pulled the point out of point slope, and then I pulled the slope out of point slope, and I used the point and the slope to create the graph. If I want to write an equation, I've got 2 points. That means I need to find the slope. So I'll have -7 minus -1 over 6 minus negative 4. So negative 7 plus 1 is negative 6. 6 plus 4 is 10. So this is negative 3/5 when I simplify it. And then I can pick one of these 2 points. It doesn't make any difference. I'm going to pick the first one. Y minus negative 1 is y plus 1 is equal to negative 3/5 times x minus negative 4, that's x plus 4. When I distribute the negative 3/5, I'll get y plus 1 is equal to negative 3/5 x minus 4 times 3 is 12/5. And then when I subtract 1 from either side, 1 of course is 5/5. So I'll have negative 3/5 x minus 12/5 minus 5/5 is minus 17/5. Okay, and there's my equation. If we look at this in a word problem, it's the same stuff I've done before. I've got to figure out how can I go ahead and figure this out. I'm designing a sticker to advertise my band. A company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. So write an equation that gives the total cost in dollars of stickers as a function of the number in thousands of stickers ordered. Okay, so there are a couple of different ways I might go about this. $225 for the first 1,000 stickers, $80 for each additional 1,000 stickers. So if I look at the rate of change, it's $80 per 1,000 stickers. Right, $80 for each 1,000 stickers. And then if we look at a data pair, I know it was $225 for the first 1,000 stickers. So we're going to be doing things in thousands. So when 225. Okay, if I want to write an equation using point slope form, I know that y minus 225 is equal to 80 times x minus 1. If we continue on with this, I know that y minus 225 is equal to 80x minus 80 by distributing the 80. And if I add 225 to either side, y is equal to 80x. I'll have minus 80 plus 225 is 145. When I want to find the cost of 9,000 stickers, that means x is going to be 9. So y is equal to 80 times 9 plus 145. So that's going to be 720 plus 145. So y is equal to $865. Okay, 865. Okay, let's take a look at another problem in a slightly different way. The table shows the cost of visiting a working ranch for a day and night for a different number of people. So if I have 4 people, it's $250. If I have 6, it's $350. If possible, write an equation that gives the cost as a function of the number of the people in the group. So what's the problem here? The problem is I've got 1, 2, 3, 4, 5 ordered pairs, but I don't have the slope. So if I want to find the rate of change for consecutive data pairs, this is the problem. I don't know if this is a linear function. I might suspect it is, but I don't know that it is. Okay, but I can find out pretty quick by calculating the slope between I'm going to calculate this slope and this slope and this slope and this slope. And if they're all the same, then I know, oh, okay. So when we have 350 minus 250 over 6 minus 4, that's going to be 100 over 2, which would be 50. Well, that's the first slope. If we do the second one, I'll have 450 minus 350 over 8 minus 6. That's also 100 over 2, which is 50. And if you look, yeah, look at this. Right here, my difference is 2, my difference is 2, my difference is 2, my difference is 2. So I know my denominator is going to always be 2, and the difference here is 100, 100, 100, 100. So it's always 100 over 2, which is 50. Okay, so my slope is equal to 50. Then I can take any one of these ordered pairs, and I can go ahead and write my equation. I'm going to take the first one. Y minus 250 is equal to 50 times x minus 4. When I distribute the 50, I'll get y minus 250 is equal to 50x minus 200. And when I add 250 to either side, I'll get y is equal to 50x plus 50. And that's my equation. Okay, so that's it for section 4.3.